Welcome to the first of this year's neuroprosthesis seminars. We usually begin these seminars by asking if there are any announcements. Okay, I do have one announcement, and that is the next seminar speaker will be October 16th. It'll be Dick Norman from the University of Utah, and it will be here in all the seminars will be in the BRB here, and the title of his seminar is Restoration of Sensory and Motor Function with Penetrating Microelectrode Arrays. And there is a complete list of the seminar series at the door, and I assume they're on the web as well. Okay, it's my pleasure this morning to introduce Dr. Takeo Kanade. Dr. Kanade is the Uncas and Helen Whitaker University Professor of Computer Science and Robotics. He's also the Director of the Quality of Life Technology Engineering Research Center at Carnegie Mellon. He received his doctoral degree in electrical engineering from Kyoto University and held a faculty position there prior to coming to Carnegie Mellon in 1980. He was also the director of the Robotics Institute at Carnegie Mellon from 1992 to 2001. Dr. Kanade has diverse research interests spanning areas of computer vision, medical and assistive technologies, and autonomous mobile robots and sensors. And he reminded me this morning that he has a recent research project in automatic tracking of migrating cells. He has a number of, over 250 technical papers and reports. He's an elected member of the National Academy of Engineering and the American Association of Arts and Sciences, American Academy of Arts and Sciences, a fellow of IEEE, ACM, a founding fellow of the American Association of Artificial Intelligence, and is the former and founding editor of the International Journal of Computer Vision. This morning, he's going to give us an overview of the Quality of Life Technology Engineering Research Center at Carnegie Mellon and the University of Pittsburgh.
I tend to have very diverse interests, so I usually show off what I've been involved. And as you see, ranging from mechanical engineering, like a manipulator design, to some of the multimedia things and computer vision and so forth. And then always people ask, what is this graph? Obviously, this is years. This is my degree of interest. Now, during this period, I certainly had I was talking some moment of fame. And one of them is I call iVision at Super Bowl. You know, movie Matrix? Have you seen movie Matrix? I've never seen it. But I was told at the right moment, the main character jumps, and then he floats in the space and he spins, or you spin around him. And the way it is taken is like this. About 200 to 300 cameras are placed round way. At the center, the character, the actor, acts. And one of the camera is an ordinary camera, so it captures all the motion. And at the right moment, all of the cameras take one picture at the same time. And then you concatenate them. Then what happens is that, you see this? At the right moment, this picture, and the next picture is this, next picture is this, next picture is this, and so forth. So as a result, you feel as if the time is frozen and you're spinning around it. So the task is to do the same for football field. Now, football field is much larger, number one. Number two, you don't know where that right thing will occur. So you cannot preset that setup. So by changing all those cameras by robotic camera, each of which, all of them are controlled in such a way that at any moment, this matrix setup is done at the right place. So that's the system. And we built such a system. We built a 1/20th scale model, 5-meter scale model in the basement of the lab. And then we actually installed it in the Tampa Stadium, second deck. One of them is like that big scoreboard. It was very tall. And it's scary if you climb there. And the distance from there to here is about 200 meters. So you can see how big zoom you need, how precise you have to control in order to capture even the player in the middle of the field, let alone align all of the camera at the same time. And then this is what we got.
Now, during today, coverage of Super Bowl 35, CBS Sports will introduce a new technology called iVision. It provides
Jim Nantz is a very nice guy.
Here at the Super Bowl, 30 robotic cameras have been mounted on the scoreboard and all along the upper deck at intervals of 7 degrees. Each camera feeds into one of the 30 specially designed digital recording devices. The images are then computer calibrated to instantaneously show any spot on the playing field from all angles within the camera's 220-degree range. Professor Takeo.
So that's me.
This is a gigantic robotic system. You have to have perfect idea of the direction, position of the cameras, and the relationship of the amount of zoom, amount of focus to the command that you give from the computer. And that is one of the hardest jobs.
This player is out, takes the pass, cuts back inside.
So this is inside the control room.
All right, here it is. This is an example during the warm-ups taken just a moment ago. The pass from Banks to Davis, and look at the way it can whip around. We're all looking forward to it. And by the way, it can be used in instant replay situations in the case of a challenge.
We will talk from time to time tonight about iVision. If you're wondering what it is, this is what it looks like.
You got a pass rush, quarterback, he drops back. Look, he sees a big lane. Look at that big lane, so he steps up into it. What always makes it easy for a quarterback is to have a clean line of sight. Watch Trent Dilfer, nice look off, looks to his left, and nobody in front of him. Look at that nice lane. He can see the receiver down the field, and what a throw.
This is a halftime show. So like that. This is actually a huge system. Each camera, from the camera to that station, 600-meter cable, wire, the Ethernet, power line, everything, 600 meter times 33. So even cable alone, it's an 20-kilometer system, cable alone. And it was fun. And so usually I say, I'm the only professor that has ever appeared on Super Bowl. And by the way, it was actually a part of the contract. The contract says that Professor Takeo Kanade must appear. It says must appear with his name and title clearly shown for 25 seconds. They said that Professor Kanade, it's in buying 1 second of Super Bowl airtime, it costs $100,000. So your appearance is equivalent of $2.5 million. That's what they said. So I had some fun. So, but I'm not going to talk about those things. So just want to show that. By the way, what I'm going to talk from now is somewhat compared with your expertise. I think I'm very amateur. So I apologize that some of the things that I say is not really up to the level of the knowledge that you have. So I have to apologize about that. Now, so having done various intelligent systems, robotics and so forth, I thought maybe it's time, we thought that it's time to think about intelligent systems which directly help people rather than the typical application that we used to have at the Robotics Institute, like military, space, factory automation. And that was called, we wanted to call quality of life technology, to help people live independently. And as you know, as soon as we think about those things, the US university culture is you write the proposal and get money to do it. So we wrote a proposal to NSF, Engineering Research Center. It was a very competitive program, and we won. So we built, together with University of Pittsburgh's very renowned group of rehabilitation and science, led by Dr. Rory Cooper. We have a program called Quality of Life Technology Center. That is what I'm going to talk about. Now, so QualtVision is intelligent system that all eventually, right now it may not be as much, augment body and mind functions that will transform lives of a large population today, basically aging people or people with disabilities, and so that we enable them to independently perform daily living activities, assist caregivers, delay and prevent manifestation of some impairment, and as a whole, increase the participation of those people into the societal activities. That is indeed the quality of life. That's what we believe, and we believe that technology can contribute to that. Now, the need for that, I think I don't need to explain this to this audience, is obvious. Demographically, it's obvious. Even the United States, which used to be somewhat younger generation, maybe because of immigration, the population is aging. 2030, we expected 20% of people will be 65 years and older. In a country like Japan, Korea, those countries, the population is much older, by the way. 30% or even higher, 2030. So my colleagues actually at University of Tokyo, who is doing similar thing, they usually show the picture in which, you know, this Akihabara or Ginza, if you have been to Tokyo, those are supposed to be younger people's place. Well, full of older people in 2030. Only you see older people. So he usually uses that kind of slides to demonstrate the need of, and then the need is not just convenience, but economically it's clear. Pennsylvania, for example, my understanding is that it increasing 8% per year, the medical expense, 8. United States economy is not growing 8% at all. So it's obvious you need to do something about that. Now, of course, we need a measure, policies, but engineering can help to alleviate some of those issues. And I think that's what we believe we can contribute. Okay, so as usual, this Engineering Research Center has the various, we call thrusts. So it is organized technically to do 3 main areas. One is perception and awareness. Basically sensor, vision, various sensor technology to be, so that the systems will be aware of what the person is doing, what the person wants to do. So that's what we call perception and aware thrust. The system has to affect the world. So we call it mobility and manipulation thrust. That studies various manipulation techniques, various mobility techniques, and so forth. And those basic functions must be communicated with users in a most convenient way, so that we call human system interaction thrust, and study various technologies for that. And then one of the important thrusts, which is not necessarily engineering per se, but this is what I think our center has good strong point, is we have this group which we named Person and Society Group, that consists of social scientists, gerontologists, clinicians, psychologists, and user groups to study and evaluate and actually conceive together with engineers, the need and also the acceptance model, how those systems will be accepted. I think we're, according to some study, most of the system technologies that have been ever developed are not used at all. And why is it? Because I think the conception, development, evaluation, marketing, all those things were done without direct input early on from the stakeholders. And I think that we will at least try to address that issue in this center. And then that's one of our features. So one thing that we found, I found at least, very interesting to me is the following. Now, a person like me who studied autonomous systems, robotics, intelligent system, autonomy is everything. We always say, I used to say, we want to develop a system that does everything autonomously, intelligent systems. Now, autonomous is actually implying as implicitly, the goal is reducing human involvement. And that is justifiable for military, for hazardous environment, for space, for industrial applications. But I think quality of life technology is not. Indeed, if we have a very autonomous system which will do everything for you while you're just sitting and thinking, I don't think you want to use them. I think you want to do yourselves what you can do. So real systems, quality of life system, is actually opposite. Systems should actually get people involved, while hopefully the system is actually capable of doing a lot of things when needed. So we came up with this equation, which you call closed systems equation, magic equation we call. Closed systems help must be equal to what person's intent minus the person's capacity. That difference, maybe plus minus delta, should be provided. If it's provide plus delta, you feel it's a little convenient. If you provide minus delta, then the system is challenging you a little bit, which will help. My understanding is things like a situation like rehabilitation, which I understand is very well known phenomena, that by challenging you a little bit, it's more effective. So this is, I think, it may be obvious to you, but at least to me, a person like me who came from autonomous system is, I think, is one of the, quote, discovery of the whole idea. So the most important thing is a system has to be, therefore, person aware and environment aware. And so we call it person-system symbiosis. They work together. And I'll tell you one of the things that symbiosis in the past used in this kind of context, but one of the things that I'd like to show eventually, and there's some little bit of that coming, is that it's not just system help people, but people actually can help people system too. And I'll give you a couple of examples later. And the last thing that I think one of the new things I believe we have to work is what I call science of everyday living. And I usually say, well, the system, science, quote, always a big thing. Science of galaxy, science of quantum mechanics. Everyday living has not been a target of science. I think it should have been. Because unless the system knows what it is to live, I don't think system can help people live. And so that's, I believe, is interesting. So as a result, of course, as a technology, various technologies are needed. It's obvious. robust perception, soft, safe manipulation, dynamic and adaptive interaction. So in a sense that those technological needs are obvious. And instead, one of the things that I think, at least for me, what I'm finding is this kind of a new way to look at technology. And lastly, I think what the ERC is supposed to do is what I just, like a person in society, new way to come up with a problem, system concept, actually develop it, and also teach them. My slogan is, in engineering school, we teach, we preach, I said. We always preach that it's important to involve users. We say it. But I don't think we have ever taught. So we say we have preached, but we haven't. We preach, but we don't teach. So we want to correct it. We also teach how to do it. And so that's another feature of this engineering center. Okay, so let me just go through quickly the kind of things that we are doing right now. Some of them are relatively benign robotics applications, like automated retrieval and stowing wheelchair, things like that. That from a robotics point of view, relatively, in a sense, straightforward applications, because it's more of an autonomy things. Also, if you combine some relatively simple motion sensor, gyro sensor, you can actually point the direction where you go, and then actually control the wheelchair. Again, that's not that difficult things, but that's doable. And we're also developing, especially Rory Cooper's group of the University of Pittsburgh is developing what we named Perma, Personal Mobility and Manipulation Appliance. We call it appliance. We want to use it every day. So the kind of thing that we're looking at is like that. Of course, the door opening kind of thing. Or that one is you're opening the refrigerator, and later you see various operations. I think we are trying to mimic preparation of sandwich. But this one is not automated, by the way. I don't think today's technology will allow us to automate sandwich preparation, which is so difficult, so difficult. I don't think it's possible. To the level, at least we can demonstrate, but to the level that actually usable. So as a realistic solution, what we're doing is a combination of user's own control by a joystick at the moment. Maybe we should need a better input interface. Also, remote control. The system is internet connected so that it can be controlled from other places, caregivers, which may be stationed in other location. Indeed, we have tested between Pittsburgh and Youngstown. And also, or in a realistic scenario, it could be between a home room and caregivers station in the neighborhood. Yeah. And one of the and then in this particular case, the remote station is actually using using the camera and using haptic interface to move these manipulator. And then, of course, the user who seeing what's happening can actually interrupt what remote controller is doing, and he himself can also control. So it's a hybrid control between three things: automated. Some of the automation, like reaching, that's easy, so automated. Some of the decision is obviously human, is much better. And some of the detailed manipulation, remote control or local control. So those tri-control are combined. And one of the comments we showed, I think interesting comments that we had at the site visit was the following, and I really like this comment. one of the site visitors said, "Oh, if this is really possible, I might be interested," he said, "doing this from my office at the lunchtime to help my father or mother." I think I really like that comment, because then, of course, that means the grandparents can probably help their grandchildren can help grandfathers and grandparents, and that's also increase the communication. I think that's the kind of thing what the technology is supposed to do, which I think I call getting more human involvement. So I think still these are very primitive system in my mind, but I think there's an interesting future to this type of applications. Now this is more automated system that works in kitchen. So some of the automation. So some of these automation of recognizing object and so forth will be used in Perma, but this one is right now somewhat independent project. We work with Intel next door to us, and then recognize object and pick object and put it in a certain place and then show it to people and so forth. Those are right now we need to put all kinds of markers and then I have some idea how to remove those markers in a nice way, rather than trying to completely make them complete automation. I think the more realistic way of doing it is to come up with a nice design of patterns. Let's say barcode, but it's not barcode. Visually, it's beautiful, but it has the information. And we can definitely design the code in such a way that it is robust to partial occlusion. So for human, it's a beautiful pattern. But for computer, it actually says almost completely everything. Therefore, the task is much easier. And then I'm envisioning maybe quote brand of plate, glasses, and so forth. And then you can just buy them. Then all of a sudden, some of those quote systems find it much easier to deal with them. And so those are definitely thinkable things. I'm actually thinking of employing computer science students with art students and then have them jointly come up with such a design. And I'm pretty sure we can do that. Okay. Computer vision technique is working on various detection of object in a daily life. It's a little dark, but like, well, certainly you need to pick up a certain object. Say, suppose you want to pick up the soup can and so forth, then computer vision must be able to recognize those things. And the planning, we have a complete planning system that actually has capability to come up with a grasping strategy without programming individual object. Because in the future, if you have to program for every object how to grasp it, it will take forever. So can the computer actually recognize, given this, we grab this way, yeah? Certain of this object, we grab this way, yeah? So what is the mechanism to decide that? And we're studying those things. And then for a relatively simple object that can be modeled by a polyhedral shape, you can actually do that. And even though I don't have a demonstration video, we actually showed that with the humanoid and so forth. So those are also coming. There are a system that we're calling virtual coach. That is the system. This is a human system interaction area. There are lots of them. One of them is like a smart chair, that the chair knows where the balance of your weight, how long you're sitting in a certain way. Are you actually awake or are you sleeping? So the chair knows that. And depending on that, the room or the chair does appropriately. temperature control, light control, things like that. And then you can think of the same idea for the floor. This floor weight by putting the sensor on the floor. The floor knows where you are, in what way your weight is shifting, in what is your gait, and understand whether your gait is changing over time. And those are definitely doable things, and some of them indeed has been done. I actually like this MemCoach. Oops. It's called MemCoach, which is also fun. This is a kind of system that is intended for people who have relatively light memory lapse, memory dementia. So idea is that we use some kind of wearable camera to take pictures at some events, say when people go to, in this scenario is zoo, or at a party, birthday party. And then those pictures are taken, and then chooser is the one, and then those they taken, so the system knows where it were taken, in what order, and so forth. Now the content, unfortunately today, we're working on the automated content analysis. The computer vision technology today can recognize things like, is it outdoor scene, indoor scene? How many people are there in general? That kind of thing is possible. But precisely recognizing who that is and so forth, where there's a lion in it, or is it a lion, or is it a dog, is it a horse? Not that well. Okay. It's okay, but not that well. But so for the time being, caregivers may give an input. Oh, this is the lion that you saw when you visited zoo, and it looked at you, and then it barked and so forth. So maybe you type in. Okay? And then at the time of viewing, those things are arranged in a graphical, in a graph matter, so that users can actually go not just in a particular order, but in a connected manner. Okay? So that way, the person has more interesting conversation with the system about the experience that he or she had. And it turns out the system actually helps people to recall more precisely. I think the main reason is, if at all, is that people may be more comfortable to talk with the system rather than with people, because they don't like people know that they forgot things, I think. And then also one of the interesting is that we are in the process of, by the way, making a company to use this, not necessarily for this purpose, but for creating your own life history. Indeed, when we showed this, one of the comments was, oh, this is interesting. Even though I do remember things, I would rather use this to create my own life history now, so that when I get older, I can show it to my grandchildren, and have a conversation with it. So it's a very interesting opportunity. So we are thinking of creating a company to actually produce such a system. And it's also interesting. And we are working on various mechanisms to handle people. Right now, we're using commercially available Segway as a base. We are developing our own version of manipulation system and small mobility system, which will actually which eventually our vision is we'll put a small, very small system, maybe put on a wheelchair, and then it actually goes and fetch things when needed, especially the areas that is hard to go. Okay. Right now it's too big, so it has to accompany, but eventually we'd like to make it small enough so that you can carry, and then kind of a dispatch from your own wheelchair. And then we are thinking of what we call inherently soft manipulation, which doesn't have any, like a elephant trunk, which doesn't have any real soft. So even when it hit object, person, it's safe, inherently safe, rather than various technology today, which use control system is used to make it safe, which is less guaranteed, because control system may fail. This is also an interesting area. That is, here's an area. This is actually lounge of a company, and by observing how people move around in that lounge, it creates some understanding of the pattern. And then interesting thing is, when a person comes, and the system in real time can guess where he is going before he actually goes. Yeah. Now you may think it's obvious because it remembers. Okay. Now the neat thing is, suppose we put a obstacle so that ordinary path is blocked. Yeah? The interesting thing is that the system can still think what? See, system knows that you cannot go there. So that's a neat thing. Now, why is this interesting? Because if the system knows this kind of thing, then this is a person aware, basically. Oops. Then ordinary, here's a robot, and then actually the person is coming. Okay, so the room basically knows where the person is going to go. Therefore, the robot actually anticipate that and then behave accordingly. Isn't that what human does? See, when we see the people just turn there, I know the person is coming this way. So that area is narrow. Therefore, I wait here because I know he will be coming. As soon as he goes there and he turns a little bit. Okay. If he's going straight, if I see that he's going straight, then I know the person is not going this way. He's going to that door. Therefore, I will probably keep going. Okay. So in other words, we call it system that knows the person as not as Newtonian object which follows the Newton equation. Human has intention. So that's what we are relying on. Is that right? In fact, I always say this. If we view people as a Newtonian object which simply follow the Newton equations, then we cannot live. For example, when we are driving like this, okay, the road is going like this. When you're driving like this, the car is coming this way, it's crash course. But you keep going. Why is it? You believe this car will follow the road and go this way. If you think this is Newtonian object, you have to stop because you will crash. So that's exactly what the human is doing. So the system should be able to do that too. That is exactly what I mean, the person aware. Okay. CMU has been working on for a long time autonomous navigation. In back 1990s, that was my project at that time. Did what we know called No Hands Across America. We crossed the United States from Pittsburgh to San Diego, 3,000 miles, 98.2% of which autonomously, back in 1995. But it's only 98%. That's not enough to let the computer drive. Okay. Indeed, I had a joke, not a joke, real actually. We drove it, actually. I drove it. But the person, the experimenter, students, was sitting on the driver's seat and then not holding the wheel, but like this. So that just in case the computer goes wrong, hold it. So I used to say, well, actually, autonomous driving is more tiring than driving yourself. That's what we did back in 1995. Now, 2007, this system, as you may know, is completely autonomous. Nobody's even on the car, and I drove. Okay? Even though it was limited area, it's an Air Force Base road, while other cars were also driving. Okay? So we're using that kind of thing to actually understand what the people are doing in such a way that can the system automatically recognize how you're doing with respect to what you should have done. So the system knows the car is coming. Are you actually responding correctly to the car that is coming at you? We can measure such a thing sooner or later automatically. And that will make this decision of evaluating drivers, which is very politically touchy issue today. Maybe you can do it more objectively, more quantitatively. So there are lots of those things, and then I can't have to. Okay, so there's a few other things that maybe I should skip. One thing I just want to say, my own interest. My own interest is vision. So I have this idea, what I named first-person inside-out vision. So this idea is the following. When we say that, well, we want to know what you are doing right now, the typical vision idea is to place a camera there and watch you. Okay. I call it system is acting as a third person and looking at you from outside in. Now, this is, of course, needed, but it's very tough. Computer vision today can detect you probably fairly okay, 90%. Detect you are there. Can track you pretty well. Though resolution is not as easy to track your gaze so that system knows what you're looking at. Now, I can somehow do that. When I look at each of you, I can tell who is looking at me, who is not looking at me. Okay. So that is actually difficult. Now, what you are most interested in, for example, when you're making a note, the system cannot look at it. Because most likely, it's actually hidden, occluded by yourself. Okay. So my idea is opposite. In order to understand what you're doing most, isn't it better system act as you by accessing your field of view, your gaze, rather than observing it from outside? Now, how can we do that? Eventually, we may implant electrode in your head and then access to your field of view. Now, you may not like it, probably. So for now, we are thinking of wearable device, which will give the computer, your field of view, what you're looking at. Then, isn't it easy for the system to know what you're looking at, what you're interested in, whether you're listening? Because, see, I see, for example, some of you are nodding in synchronization with what I'm saying, then system, of course, can tell that you're nodding. Much easier than detecting it. Because the motion of the nodding is so small with respect to this camera. Whereas from your point of view, it's actually moving a lot. So it's not that difficult. Okay. Moreover, today storage is so cheap. Sooner or later, one square inch will contain more than terabyte, which is equivalent to remembering all of the pictures, all of the sound that you have for about a month. Okay, so which means that most of the time, what you see now is one of those pictures that you saw the other day. Okay, especially for older people's living. So the system actually knows where he is, what the person might be doing next, and so forth. And all those technologies coming. It's called data-driven technique. So that's our ambition. And so when the person sees a scene, System knows where you are, what building you're at, what you're at, whether you're a bus, are you walking, waiting, sitting, what you're looking at. And also, the system may understand what other people are doing. And I like this video. See, the person is picking up. Now, today, the computer vision actually can recognize that you are picking up something. So whenever somebody pick up, see. Now, these are the video that we took. So naturally, we have a bias so that we know how our system works. So we actually look around and say, is there any publicly available video that involves a picking up? Here's a YouTube video. There are lots of them. Lots of them. OK. So can the system automatically recognize? This is a little more difficult. This is more. Why are they there? Apparently, there's a game where you place the coin and then take video secretly and bet who will pick that coin first. And so our system will be used, automated judge system of that game. Okay, so seriously, various action, understanding, and so forth. By the way, we can system can understand the three-dimensional environment and so forth. We're building hardware, and this is a kind of video that we can get outside from system. And by the way, analogy is basically the same as the movie. From time to time, the movie shows the main character moving. From main character point of view, you can tell what the person is going to do next. Right? That's our point. Okay, so all right, so we are designing all these systems and building, and lots of different design. And I have lots of other things to say, but let me. Interesting opportunities may exist. Okay, so maybe I should stop here, and then just want to say that we are also developing for daily living science of daily living. We are actually capturing a large amount of data of people doing everyday activity, and then publish all those data on the web, so that any researcher in the world can use them, so that they can study the how people move, what kind of action they do when they cook, what kind of motions, what kind of sequence they have. And we want to really develop such a thing. So let me see. So finally, we're working with industry, and as I said, we are doing lots of successfully producing a couple of companies. This is one interesting company that is a very simple byproduct of some of the study. It's a jacket that vibrates, and I haven't taken it. I was told by people who did it. It was really nice sensation. And we see there's some commercial possibilities. That basically you can. The original idea was to communicate with people have a hearing problem by vibration, but it turns out even one can hear when that vibration is synchronized with some music. It's a real sensational, great sensation, and a great entertainment device. And I heard that when we demonstrate this, people made a line, and then people will never really wanted to test it. So we thought it's an interesting opportunity. And so like that, we have a various commercial activity too. So I kind of rushed, but I hope that I conveyed that idea of using various advanced technology of sensing, decision making, artificial intelligence, and so forth can be used for intelligent systems to help people to live better life, to live more independently. And that's our goal, and it's just the beginning. You see, obviously, we're not doing as much as we should, but I think it's a good beginning, and I think we're learning a lot. So thank you very much.
Well, Takeo, thank you very much. Just as a token of our appreciation, we have a small gift for you. And we would like to open this up now for questions. And if there are people watching this over the webcast, you can email questions to me, and I'll check my email and see what they are. My email address is pec3@case.edu. It's on the web anyway. All right. So, questions? Tom.
I was intrigued with your MemCoach. I've reached a point in life where I might not find it more and more necessary or valuable. And then I was intrigued with the idea of incorporating a barcode into art. And then with our community's fascination with tattoos, what I'd really like to have is be able to recognize, I'd walk down the street and this thing would whisper in my ear, Pat Crago, Corey Crago. So they would give me some family and history, and then I could say, oh, hi, Pat, how's Sharon?
So the question is, he liked the idea of MemCoach and, this memory thing. And he's saying that by using the vision system or this wearable system, it may actually remind you who the person you're talking to and so forth. Yeah, absolutely. In fact, we are serious about that, and yes, indeed, we are very serious about that, and we are indeed trying to build such a system, which you call "Who's That?" or and where are you, and so forth. And in fact, more seriously, it may have very interesting application for not only and also autism people, to help autism people, and then students, and also the retailer as well, because what retailer wants what you're doing at their store, in what way. And yeah, in fact, this particular idea I had a long time ago. Back in 1985, I actually proposed this to DARPA manager, then my sponsor. And he said, no, Takeo, I don't want that. He said, if you have that, exactly what you said, you would probably tell me, he said, Takeo, you would probably tell me, oh, so-and-so, you promised $250,000 last time. I haven't received it yet. So he said, no, I don't want that. And then, so I didn't do that at that time. But I think seriously, I think people are very much interested in that kind of thing. Now, I think one of the challenges, do we want that to be very conspicuous and so forth? So of course, by the way, privacy is a big issue in this kind of thing, privacy. I have other stories about how the privacy comes into play, this kind of thing, but definitely visual memory privacy is important, is an issue, and in fact the Person and Society Trust is really studying for us, together with us, how people will accept this kind of device, and how can we make it more acceptable in the society. Yes. Yeah.
Yes, I had a question about the Perma device that you showed. It seemed to me that the food preparation was done at a distance because of the size of the manipulator. How do you envision that system helping the individual once the food's finished? Is the robot going to help them actually eat close into their body too, or I guess I saw sort of a discrepancy there between the.
I see. So the question is that yes, Perma may or is set to help preparation of the food once it's prepared. How about the eating process? Yeah. Well, yeah, it's a part of it actually. Well, right now you see the Perma, the manipulator that we use for the experimental system of Perma is too big. It's gigantic and it's scaring indeed. Scary. So that's one big mistake. And as I said, we're designing new ones. Hopefully it's better. Now speaking of eating, there is already a certain system even on the market. In Japan, they call My Spoon. There's a tabletop system which actually feed you from sort of a lunch box like plate. Now, so I think technically definitely doable, definitely doable. So the question is, do we want those systems to be specialized for individual tasks, or some of the system can do multiple purpose? I think technically those are the questions. Technically how to do it, I don't see that much. Well, I shouldn't say it's easy, but it's probably fairly doable things. Doable things.
Speaking of the special purpose versus general purpose technologies, some of the wayfinding systems that we showed, they're still in constrained environments where the structure of the environment's known. So could you talk about the challenges to opening that up to the community, or a street or shop in downtown Pittsburgh is different than one in Kansas City?
I see. So the question is, yes, we showed path planning, but the environment was limited. Can we do that in much bigger scale, community and so forth? I would say yes, especially community is not that difficult. Today, you'll be surprised at how much it's known of the environment already. If you go to the company like Navtech and so forth, they collect all kinds of things, and then they're digitizing three-dimensionally, so if sooner or later we'll know that. Now, of course, it does not know the particular object which you placed yesterday. Okay, so it has to scan. Now, when it comes to the technology to scan three-dimensionally the environment and recognize the obstacle, compare it with the currently known map, and then detect changes. Those are, I would say, fairly available. We've been working on that kind of thing for a long time. Today, the difficulty is, of course, we're talking fairly expensive sensors, at least a few $1,000s, probably several $1,000s. They will never make in this kind of market. However, lower cost 3D range sensors are coming. So I think as soon as the sensor price issue is done, I think a community thing is indeed, in one sense, could be a little easier. Could be. For example, walking the nearby street and so forth. So one of our ideas, plan, is that we are using a community called Maquis area, and we digitize the whole area, and then actually demonstrate the Perma, that kind of vehicle moving in that community. So I see that is a good possibility. Yes. Yes.
Well, first, thank you for your. It's really an interesting and fun presentation. It's it's so complementary to what we do. As we were talking last night, it's really very enjoyable to see this. So my wife worked in a we didn't talk about this last night, in a multiple care environment for so many years. And one of the things that I learned in this, from her experience is the desire for people to remain home as long as possible. I mean, I think we all know that, even personally. And I can envision, this sort of technology, being an instrumental part in enabling people to stay in their home for much longer periods of time. And of course, the cost savings associated with that are enormous as well. So not only are there societal benefits, but there are societal benefits. So my question really has to do with, since you're doing so many things, how do you prioritize the type of activities that you undertake in this center that are sort of, that make it, that identify its relevancy to whatever measure of relevancy that you have. It's that, because there's so many opportunities here that that you're presenting, and even more that you, I'm sure, envision. How do you decide which of the areas that you go into?
So the question is, it's obvious these systems will be used to, the important goal is to make it possible for people to stay their home long, and then for that purpose, even though I talked lots of things, what are the criteria? In what way we can select various projects? That's exactly what we're asked every time by NSF. Yes, that's right. Now that's always difficult. Now I think our answer is, at least my strategy is, I call it shotgun approach. We do lots of things, and then of course we evaluate them by using the Ph.D. Personal Society Trust. And we're fairly optimistic right now, because what we are finding, at least to me, is that what we thought extremely good idea may not be a good idea. What we thought the stupid, simple idea or some idea is really good. And so I think we certainly do a fairly due diligence study of relevance by Ph.D. and evaluate that. That's a formal process. But as a ERC strategy, I may not tell this to NSF people, don't tell them. I personally like to be opportunistic, take opportunistic approach, and at least that's what we're doing. And in fact, lots of things that I showed here are not necessarily funded directly by ERC. And I believe that's a correct approach for now. Yeah. But I agree it's important to prioritize, and for that purpose, definitely we know we do actually evaluate possible number of users, scenario, cost, performance, cost and so forth. Scenario including cost and so forth, in which certain system will be indeed make an impact, and we do have actually such a process of evaluation. But having said that, I think my feeling is, frankly, doing the way that we're doing, I think at this moment is fairly justifiable, because after all, if you see many things, each one is actually developing some fundamental ideas and techniques, each of which will definitely be usable for other things anyway. So I thought that's okay. Now, I'm not giving you a very good answer. Indeed, I have to prepare a better answer for my next NSF site visit. Thank you.
Time for one more question.
All right. Is there anybody else?
Okay. Other, okay.
So the area of cognition, you gave Tom asked the one, but is so impairment, memory loss, and restraint.
Hey, we don't have to be that definitive.
That is a JTM. You know, I wonder if there are other examples of undertakings that you have in, you know, in the area of cognition and memory, and, you know, and
I think, well, okay, what other cognition area we are working on? Right now, it's only memory. So we're that is a MemCoach is the only one, but that's a stored one. What we like to do is actually more of a what we may call job coach. So when you go to start something, the system knows that you started something, and then you're about to do something like open the refrigerator, extend your hand to grasp, say, egg, and you kind of freeze what to do next. Or I forgot the name, the head injury, which
traumatic brain injury.
Yeah, and then when you're sweeping the room, and then when you finished, then you forget that fact that you actually finished. I'm pretty sure our ideas like a first-person vision will definitely easy to tell that you forgot it, therefore you finished it, therefore it's a next step to go to the next step.
That's sort of the things I was thinking about is some of these things that are, you know, would be, you know, clearly I would think relevant to traumatic brain injury, and, you know.
Right. So that we call job coach, and that is the area we're not doing as much right now, but that's definitely an area we're thinking, and it's obvious that some of the first-person vision capability, or even some much simpler sensors, which will tell you, with which we can guess what you're doing, then may be able to advise you that, oh, you may be forgotten doing this and that. Because those people are definitely capable of doing anything. Yes, just forgetting some.
Yeah. Okay. I mean, and clearly a huge area of need with, you know, that has a dearth of good ideas in it as well.
Right.
Yeah.
I think that might be an interesting thing to apply to people with obsessive compulsive disorder, to see if you can treat that with that concept.
Oh, what is that?
Obsessive compulsive, well, for instance, repeated washing of your hands.
Oh, I see.
So you could say, you've already done that once, you don't need to do that again.
Oh, okay, that's a good idea. I see. Right, so those are basically what I call application of person-aware technology. If the system knows what you're doing, what you have done, and it can remember probably far better than anybody, because the system remember. You can even have a statistics how many times you did this and that, you know, of course, and those are easiest thing for computer to do. Therefore, yeah, I like that. Thank you very much.
Okay.
I'll remember that.
Very short, maybe short one?
No, not a question. I'm just saying, it seems to me that your memory system is a great security application for people doing security, that they could record continuously what they're observing.
I see. Okay. Yeah, I have several other applications with those systems, which I did not have a chance to talk. But one point is that, like a driving, until complete autonomous driving system will come, which is a long way to go, you are still at the driver's seat, and the computer is actually helping you. Then what you're doing is indeed, even when you may not be a perfect driver, is a good help to the computer. Because I usually say, after all, isn't the human the most intelligent computer on a car? Therefore, if we can observe, if the system can observe what you're doing, where you're looking at, how you're moving, wheel, the axle and so forth, computer should be able to make a sense, together with its own understanding of outside, where the road is, where the other cars are, where the people are. It should actually get that help, get what you're doing, use it as a help, important help, to make better decision than doing it alone. And I think that's exact what I would call person-system symbiosis, where the person is indeed helping the computer. And that's the one area I feel very interesting, new way of approaching, quote, autonomous system, instead of getting rid of human involvement. Okay.
Thank you very much, Professor Kanade.
Thank you.